Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Proving Lines Parallel. If you just watched my video about parallel lines, you would have found out that a lot of relationships happen when you're given parallel lines cut by a transversal. So to prove lines are parallel, you just need the converse of blank angles. And you can put in corresponding alternate interior, alternate exterior, etc. So by reversing them, basically with the lines, two lines cut by a transversal, those are if and only if statements, really. So if it works forward, it also works in reverse. Okay, so what does that mean? Well, if I were to draw an image, and instead of using two points to name the letters, I'm going to use the cursive lowercase letter to name them, which is acceptable. Let's say we have lines L and lines M, and they are cut by a transversal T. It's not a very good cursive T, but. And then I mark angle 1 and angle 2. Now, because I've marked them with one arc each, that's me saying they're congruent. So given that angle 1 is congruent to angle 2, then L must be parallel to M by the converse of, and if you'll notice, they're on opposite sides of the transversal, right? Your transversal is right here. One is on this side, one is on this side, but they're in between the parallel lines. So that's the alternate interior angle theorem. And I'm okay abbreviating in my classroom. You just have to check with your teacher whether or not. So that's one thing that you can talk to your teachers about is, one, how would they like you to write it? I like my students to know the words. So because they're alternate interior angles that are congruent, we have parallel lines. If they weren't congruent, we don't have parallel lines. So keeping that up. You also, around this time, might start coming up with a new proof called a flow proof. If you're taking an EOC in Missouri, you're probably going to see this as a drag and drop. Okay, so I'm just going to go ahead and give you a pictorial of that, and it's based off this. Okay. They also, let's see, actually I'm going to give a new image. Okay, here's our line L. Here's our line M. You'll notice there's no arrows on it, so while they appear to be parallel, which I use the lines on the paper to help me with that, there's no guarantee. And here's our transversal. And angle 1, angle 3, and angle 2. Okay. So I'm going to do this slightly different than the last one. We know, based off the given, and I'm actually going to mark these, okay? We know the measure of angle 1 is congruent to the measure of angle 3, and that's because of vertical angles. And you'll see that in a box. We also know that it was given that the measure of angle 1 is equal to the measure of angle 2 because it was given to us in the image. That's what that arc means. So we could put these boxes together and say that the measure of angle 2 is equal to the measure of angle 3, and that would be by substitution. Now, some places you might see it called the transitive property because if 1 is congruent to 2, or sorry, if 2 is congruent to 1 and 1 is congruent to 3. So I would accept substitution or transitive. Okay, and we notice that 2 and 3 are in corresponding locations. So that means L must be parallel to M due to the converse of the corresponding angles theorem. And this would be considered a flow proof because it's just a flow chart. So any rule that you've learned about parallel lines is true in reverse as far as the course. So the converse is going to hold true. So you can use that to say things are parallel. So I want to explore that transitive property just a little bit more so we understand it. So L is parallel to M. M is parallel to N. Notice I haven't said anything relating L and N, but I bet you already know something about it. So I'm going to draw line L parallel to line M. Well, and then it says line M is parallel to line N. So can we conclude anything? Yes, we absolutely can by transitive. L, see how the M is the duplicate? Since L goes to M and M goes to N, couldn't we compare those as well? Yes. So that's what the transitive property. We can now conclude that L is parallel to N. Okay. Let's think about if line A is perpendicular to line C, and these are supposed to be cursive. Ooh, hey, focus. And B, that's a cursive B, is perpendicular to C. Then what? Okay. Here's line A. Here's C. It's perpendicular. Well, B is supposed to be perpendicular to C. So I'm going to come in here and put a B perpendicular to C. What do we notice about A and B? They're parallel, aren't they? A is parallel to B. I'm trying to do my cursive. And we can state that because, look at this, corresponding angles, right? Converse, corresponding angles. So again, anything that you can say is true in forward about a parallel line is also true in reverse. If I tell you their angles have that relationship, then you can guarantee that the lines are parallel. Now, just a quick note. If I give you two lines cut by a transversal, these are very not parallel. I purposely drew them not parallel. Can we make any assumptions about these? And the answer to that is no. If they're not parallel, you can't make assumptions. So we have no relationships here because we did not start with parallel lines. So make sure that you're keeping true to the full format that you have to have. This is a special relationship for parallel lines cut by a transversal and nothing else. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.